Hello everyone, in this lecture we are going to discuss exercise 1.3 and here the first example is make the correct statement by filling the symbol subset or not subset in the filling the blank. So firstly we see the meaning of this notation. Here if we write A subset of B, that means every element of set A is a member of B. If we are saying A is not subset of B, that means at least one element in set A which is not the member of B. That's why we are saying A is not subset of B. Here in this first example, first set contain element 2, 3, 4 and the same element contain in this set. That means all the element of this set contain in this one. So we can say this set is a subset of this one. So here set is a subset of this set. So here the notation is this. Now here in second example, first set contain ABC element, second set contain BCD element. Here AB is common but A element is a member of this set but it is not the member of second set. That means at least one element in this first set is not the member of set B. So we can say it is not a subset. So in filling the blank we have to put not subset notation. Now in third example, first set is a collection of X such that X is a student of class 11 of your school, and second set is a X such that X is a student of your school. Now see here, if we are saying it is a collection of 11th class student of your school, so obviously all the student of your school is already contained all the student of class 11th of your school. That means this all the student is member of the school. So here it is a notation subset. So now in fourth example, this set is a collection of circle in a plane and second is collection of a circle in the same plane with radius 1 unit. Now here it is a restriction that radius must be 1 unit. In first collection there is a collection of set, that means it taking the all possible सर्कल्स और यहाँ पे क्या है, सिर्फ जिस यूनिट रेडियस वाले सर्कल का कलेक्शन है. दैट मीन्स इट इज़ नॉट ए सबसेट. फिफ्थ वन इज x such that x is a triangle in the plane, and here second set is x such that x is a rectangle in the plane. So here it is a collection of triangles and it is a collection of rectangle. Again here triangles is not a subset of collection of rectangle, and second is a x such that x is a triangle in the same plane. So if we are collecting all the possible triangles, so it contain equilateral triangle also. So here the first set contain equilateral triangle, is a subset, it is a subset of our set B. So here first set is a subset of second set. In seventh example, here x such that x is an even natural number and here x is an integer. We know that in the set of integer it is a collection of even as well as odd numbers. So all the even integer is again a subset of set of integer. So in this example, first is a subset, second is not subset, third is a subset, fourth one is not subset, fifth is again not subset, sixth one is equilateral triangle, it is a subset, and last example is again a subset. So this is our first case. Here in the second example, examine whether the following statement are true or false. Now see, we know the meaning of subset and not subset. So using that knowledge we have to decide whether our statement is true or false. Here the first set is collection of AB, second set contain A and B element. Here the ordering of element is changed. B is contained in second set first position and A is contained in the third position. But every element of first set is a member of second set. That means here the first set is a subset of second set. So we can say this first example is false. Now in the next example, now see the second example. Here set A contain element A and second set contain element collection of all vowels in English alphabet. In English alphabet all vowels, that means this set B contain element A, E, I, O, U, and here first set contain A. So all the element of first set is a member of this second set. Hence the second statement is true. So this one is true. Now in third example, first set contain element 1, 2, 3, second set contain 1, 2, 5. So here the first set member 2 is not the element of this second set. That means first set is not subset of second set. But here it is given subset. That means this statement is false. In fourth example, set of singleton element contains set A is a subset of this one. So yes, it is correct, clearly visible that the first set contain only A and which is the member of second set. That means this statement is true. Now in fifth example, set A is belonging to the set of A, B, C. Now here set A, that means this set contain element A, and here set A, B, C, it contain element A, B, C. So these are the element belonging to this set. So we can say this A is belonging to set B, B is belonging to set B, and C is belonging to set B. So these are the element belonging to this set. But it is nothing but if we are writing curly bracket set A, it is a set, and here set is a subset of this set B, but it is not belonging to the set B. So this statement is wrong. That means this statement is false. Now the next example, the first set is a collection of x such that x is an even natural number less than 6. So here this set, if we write in the list form, then it contains element 2, 4, and in second example, it is collection of x such that x is a natural number. So it is collection of all natural number. That means this set is a subset of natural number. Hence this statement is true. So here our first statement is false, second statement is true, third statement is again false, fourth statement is true, fifth statement is false, and last statement is true. Let's see the next example. Let A is equals to collection of 1, 2, set of 3, 4, 5. Which of the following statements are incorrect and why? Here set of 3, 4. It is a set, but it is the member of set A. That means it is like a element. Just like 1 is the element of set A. So we can say 1 is belonging to set A. 2 is an element of set A. So we can say 2 is belonging to set A. So here set of 3, 4 is an element of set A. That means it is belonging to set A but not a subset of set A. So this statement is wrong. And here this one is correct. Because if A set contain set of AB, so this is the element of set A. So element are belonging to set A. We have to use the symbol. And if we are saying set of A, so set of A क्या होता है? It is a subset of set A. So here 3, 4, it is an element of set A. So it is belonging to set A, not a subset. Now third is set of element. So just like this example, set of A. So singleton set, we are writing the element that is a subset of set A. So set of element of set A is a subset of set A. So this is the correct statement. Now here 1 is belonging to set A. Yes. So it is a true. 1 is subset of set A. No, because 1 is just an element and element is belonging to set A, not a subset. If we are taking the set, then maybe it is a subset. So this is the wrong statement. And in fourth example, here set of 1, 2, 5 is a subset of set A. So it is a true statement. Why? Because कोई भी set आप consider करो. Suppose set A contain element A, B, C, and from this set we have to collect some element. So suppose we are collecting 1 A, C. So this is always a subset of our given set. You can take any element from the given set A and make the new set. That set always a subset of given set. So this is the true statement. Now next is set of 1, 2, 5 belonging to set A. This belonging to symbol we use only for the element which is belonging to set A. So given set does not contain element, that element is set of 1 to 5. So it is not correct. Then next is set of 1 to 3 is a subset of A. It is again wrong. Why? Because set A contain element 1, 2 but not contain 3. 3 is not element of set A. See here, it is a collection of element of set of 3, 4. So 3, 4 ये क्या है इसका complete जो set है, it is a element, but single 3 is not the element of set A. So यहाँ से set A में से आपने 3 को उठाया ही नहीं है, so वो उससे जो set बनेगा that is not a subset of given set. So this statement again wrong. So here this statement is wrong. Now see the next example. Empty phi is an empty set and it is always subset of every set, but it is not the element of a given set. If we are saying phi is an element of set A, then set A contain phi A, B, C. Okay, so this is not the correct statement. See the next example. Here's phi subset of A. So here empty set is always subset of every set. That means this statement is always true. What about this one? Set of empty set is a subset of A. Here empty set is not sub element of set A. Just हमने इस एग्जाम्पल में देखा था, और सेट में से कुछ एलिमेंट उठा के अगर आप उसका न्यू सेट बनाते हो तो दैट सेट इज ऑलवेज सबसेट ऑफ गिवन सेट. बट ये एलिमेंट ही नहीं है, तो उससे जो आप सेट क्रिएट करोगे दैट इज़ नॉट द सबसेट ऑफ गिवन सेट ए. सो दिस इज द रॉन्ग स्टेटमेंट. तो नेक्स्ट एग्जांपल इज राइट डाउन द ऑल द सबसेट्स ऑफ द फॉलोइंग सेट्स. सो हियर फर्स्ट एग्जांपल, all possible subset to empty set is always subset of every set, and second is singleton set A. So हर एक set खुद का subset रहता है, so that's why this is a two subset for given set of A. Now what about this next example? So here again empty set and itself, ये दो तो इसके subset रहेंगे. Now next is we have to take some element from given set and make the new set. That is here, if we take the A and make the set, then we get the singleton set A. Singleton set B is also a subset of a given set. Next choice will be, we are collecting the two element which is nothing but a given set. Now here in this example the set contain three element. So here first subset is empty set, second set itself, that is a one set of 1, 2, 3, and next is if we take single element 1, then we get set of 1 is a subset of given set, then single element 2, single element 3. What will be the next choice? Collect the two elements. So set of 1, 2 is a subset of given set, then next set of 2, 3 and set of 1, 3. So these are all possible subset to this given set. What about our last example? Empty set. So phi is a null set. It contains no element. So here there is no choice to take any element from the set phi because it is an empty. So empty set has only one subset, that is nothing but phi itself. See the next example. How many elements has P of A if A is empty? So here A is our empty set and we know that empty set has only one subset, that is a set itself. And here P of A is the notation for the power set and that is nothing but collection of all possible subset. So our given set has only one subset, that is nothing but set itself. So here power set contain only phi. So total element in a power set A, that is denoted by this symbol, that is called a cardinality of power set, which is nothing but 1. And if you know the formula of finding cardinality of power set, so it is a simply cardinality of set A. Here the set A is our empty set. The cardinality, that is total element contained in phi, is 0, and cardinality of power set, A, formula is 2 raised to power n. N is nothing but the number of elements contained in set A. So here cardinality of set A is 0, that is 2 raised to power 0, it is equals to 1. So here these two methods to find the number of elements in a given power set A. Next example is write the following as an interval. Here the first is set of x such that x belonging to set of real number and minus 4 less than x less than equals to 6. So minus 4 less than x less than equals to 6 and x is our real number. That means we are taking all real number from minus 4 to 6. अब इसमें क्या हो जाएगा, -4 के बाद में जितने रियल नंबर्स आते हैं उन सभी को कलेक्ट करना एक एक एलिमेंट से पॉसिबल नहीं. सो वी हैव टू राइट इन द फॉर्म ऑफ इंटरवल. सो इट इज़ नथिंग बट open interval -4 to close interval 6. We are used the open for -4 because 4 is not involved in this set and 6 is less than equals to 6. That means 6 is also including in the set. So here we have to take close bracket when the element is included. Now what about this second example? -12 strictly less than x strictly less than -10 and it is a strictly less than symbol. That means it is a open interval -12 to open interval -10. So in this collection of all the element which is belonging to this interval, this is nothing but this set of x such that x belonging to R. Here 0 less than equals to x less than 7 and again x is a real number. So it is a closed interval 0 and open interval 7 and here it is a less than equals to use on both sides. That means it is a close interval 3, 4. Write the following set in a set builder form. जिस तरह से अभी set builder form से हमने interval के form में express किया, same way here the intervals are given, we have to write in the set builder form. So here the first is open interval -3, 0. So it is collection of all the real numbers. So here set of x such that x is a belonging to set of real number, but we are not taking all real numbers. We just have to collect from -3 to 0 and here -3 is not including. So here -3 strictly less than x strictly less than 0. So this is the set builder form for given interval -3, 0. So the next example is what universal set will be you propose for each of the following. Now here we have given statement. First is the set of all right triangles and second set of isosceles triangles. So if we consider the set U is a collection of all the triangles, then collection of all the triangles contain right angle triangle as well as isosceles triangle. So collection of triangles is a universal set for these two sets. Now see the next example. Given the set A contain element 1, 3, 5, set B contain element 2, 4, 6 and C contain 0, 2, 4, 6, 8. Which of the following may be considered as a universal set for all the three sets A, B and C? So here set A is a subset of universal set, B is also subset of universal set and C also the subset of universal set. That means every element of set A, B, C are member of universal set. So let's see here. Here in the first option 0, 1, 2, 3, 4, 5, 6. But it is not contain 8 and 8 is the element of C which is not the member of our first set. So here 8 does not contain. That means it is not a universal set for given set ABC. Now see the second. Second is a completely empty and universal set contain all the element of set ABC. So second is again false statement. What about the third example? Third set if we observe then it contain 1, 3, 5. That means all the element of set A contain in this third set. What about the elements of B? 2, 4, 6 contain in this set. And next Element of C, 0 is there, 2, 4, 6 and 8. So this is universal set for given set ABC. What about the last option? Here element of C is 0, which is the not contained in this set. That means this is not a universal set. So correct answer is option number 3rd.